Okay, here given a function h of t is equal to a dt minus 16t squared, we want to find for part A what this h of minus 2 is. For part A, to find h of minus 2, you look at h function and you substitute for each t minus 2. So you have 80 times minus 2. Then here we have minus 16 times, you have minus 2 to the power of 2. We need to evaluate that. So if we have 80 times minus 2, that gives me minus 160 minus, here's 16 times negative 2 square, that would be the same as 4. Negative 2 times negative 2 would be equal to 4. Negative 16 times 4 would be 64. So that adds up to minus 224. That's h of minus 2. For part B, they're asking for h of A. So we substitute for each ta now in h function. So it would be 80 times A minus 16 times A squared. That is h of A. For part C, it says find h of t is equal to 0, h of t greater than 0, less than 0, graphically. So let's take a look at h of t is equal to 80t minus 16t squared. If I let that be equal to 0, here we are factoring minus 16t, you get minus 16t times t minus 5 equal to 0. So if you solve for t, you get minus 16t is equal to 0. That gives you t is equal to 0. Or t minus 5 is equal to 0. T is equal to 5. So here they're asking us to solve this graphically. So if I look at the graph of this is my y-axis and this is my x-axis, and a minus 16t squared plus 80t, this is a parabola that opens downward. Coefficient of t squared is minus, and looks like that the x-intercept we just found would be 0 and at 5. So roughly your parabola look like going down. We don't really have to find a vertex here. For part C, the solution would be 0, 0, and other solution would be 5 and 0. So the two solution would be 0 and 5. 0 and 5, these are the solutions when is equal to 0. For part D, when the function is greater than 0, then would be all the values that are from 0 to 5 are running this in interval notation. So all these values between 0 and 5. And when it's less than 0, would be all the value from negative infinity to 0 and from 5 to infinity. So for part E, I can write this as, for part E, the solution would be all the number from negative infinity to 0, and union means we're going to include also all the numbers from 5 to infinity. Here is given the table, the values for x for f of x and the values for x for g of x and corresponding value for them. We want to part A, find composition of f respect to g of 1. So first thing we need to translate this. Composition of f of g respect to 1 means f of g of 1. So g of 1, we're going to look at the g function here. This is the g function. G of 1 when x equal to 1, g of 1 would be equal to 4. So g of 1 is equal to 4. So this is 4. So we're really finding f of 4. Now for f of 4, I need to go back to my f function. When x equal to 4, what is f of x? Is 6. So f of 4 is equal to 6. This would be composition of f of g of 1. For part B, g of f of 1, that's the same as g of f of 1. So I have to look at the f function now and see what happens when x equal to 1. When x equal to 1 in f function, f of that is equal to 2. So we're really finding g of 2. Okay, g of 2, look at the g function. When x equal to 2, that would be equal to 3. So the answer here would be 3. For part C, we're going to find composition of f of g of 7. It means I have to find f of g of 7. G of 7, look at the g function, x equal to 7, g of that would be equal to minus 1. So now I have to find f of minus 1. Well, when x equal to minus 1, for f of x, when x equal to minus 1, f of x is not defined. There's no number correspond to that. So there's no solution here. Okay, here we're going to solve and check the answer. We have absolute value of 2x minus 5 minus 3 is equal to 3. First step is to isolate the absolute value. So I'm going to add 3 to both sides of the equation. So we get absolute value of 2x minus 5 is equal to 6. When absolute value of x is equal to a number like k, x would be equal to plus k or x equal to minus k. So in this case, instead of x, you have this expression here. You have 2x minus 5 is equal to 6 or 2x minus 5 is equal to minus 6. You have to solve both of these. Here I'm going to add 5 to both sides of the equation. You get 2x is equal to 6 plus 5, which is 11. Divide both sides by 2. You get x is equal to 11 over 2. Or here again add 5 to both sides of the equation. You get 2x equal to negative 6 plus 5 would be minus 1. Divide both sides by 2. X equal to minus 1/2. Also it says to check the answer. So we're going to substitute for each x 11 over 2 and for each x minus 1/2. See if it works. Okay, here we want to check the answer for first one. If x is equal to 11 over 2, we're going to substitute for each x 11 over 2 and see if that's going to add up to 3. That's a question. Question mark. Okay, so here this 2 reduces 11 minus 5, so that would be absolute value of 11 minus 5 minus 3. Is this equal to 3? That's the question still. We have 11 minus 5, that would be absolute value of 6 minus 3. Is it equal to 3? That would absolute value of 6 is 6. Yeah, 6 minus 3 is equal to 3. Yes, 3 is equal to 3. So yes, the one solution would be x is equal to 11 over 2. And the second one, we do the same. We just multiply 2 by minus 1/2 now. Minus 5, minus 3. We're going to see if this can add up to also 3. This 2 cancels. This 2, absolute value of minus 1, minus 5. Alright, so that would be minus 3 here. Absolute value of minus 1 minus 5 would be minus 6. Absolute value of minus 6 would be equal to plus 6. 6 minus 3, yes, that also is equal to 3. Good. So the next answer also is correct. Yes. X is equal to minus 1/2 also is the solution. Okay, here we want to solve and check the answer. We have absolute value of expression is equal to absolute value of another expression. If you recall, we can just ignore the absolute value sign on the right hand side. When you have absolute value on both sides, we can just take away one of them and then proceed. So here, just like before, if absolute value of x is equal to k, either x is equal to k or x equal to minus k. So instead of x, we have x minus 5 would be equal to 2x plus 3, or x minus 5 is equal to minus 2x plus 3. We need to solve these. Here I can move all the x to one side of the equation and all the numbers to the other side of the equation. So we can go ahead and subtract x from both sides of the equation here. You would get minus 5 on the left hand side. You get 2x minus x give you x plus 3. And here subtract 3 from both sides of the equation. Looks like x would be equal to minus 5 minus 3 would be minus 8. That's one solution. Here I'm going to distribute the minus with the minus 2x minus 3 equal to x minus 5. Here I'm going to go ahead and add 2x to both sides of the equation. So I can move all the x to the left. 2x plus x would be 3x minus 5 is equal to negative 3. Add 5 to both sides of the equation. You get 3x equal to 5 minus 3. It would be equal to 2. Divide both sides by 3. Second answer would be x equal to 2 over 3. So now I need to check the answer. Okay, here we're going to check our answer if x is equal to minus 8, if that is the correct answer. I'm going to substitute for each x minus 8, would be minus 8 minus 5, absolute value of that. The right hand side we do the same thing, 2 times minus 8 plus 3, absolute value of that. We have minus 8 and minus 5, that give me absolute value of minus 13. So on the left hand side you get 13, and here you get 2 times minus 8 minus 16 plus 3, so that give me absolute value of minus 13. Yep, that's 13 also. Yes, x is equal to minus 8 is one solution. We're going to do the same thing with the other one. If x equal to 2 over 3, let's go ahead and substitute for each x. 2 over 3, it's minus 5 over 1. Is it equal to 2 times 2 over 3 plus 3, absolute value of that. Okay. Here we have 2 over 3 minus 5 over 3. We need to find the LCD. So the LCD is 3, so I need to multiply this by 3 over 3. Alright, so I would get absolute value of 2 over 3 minus 15 over 3 on the left hand side. So I get 2 minus 15, they give me minus 13 over 3 on the left hand side, so that would be 13 over 3. Let's see if I get the same in the right hand side. Here I get 4 third plus 3 over 1. LCD still is 3, so I will write this as 4 third plus 3 over 1, multiply this by 3 over 3. So here you get 4 plus 9 over 3. 9 plus 4, that is 13. That would be 13 over 3. Yes. The second one is the solution. X equal to 2 over 3 also is the other solution. Okay, here we're going to solve and graph the solution. You have absolute value of x plus 1 plus 2 is less than 5. The first step is to isolate the absolute value, and so I need to subtract 2 from both sides of the inequality. I get absolute value of x plus 1 is less than 5 plus 2 would be 3. Okay, let's see what that means. Absolute value of x is less than 3 means all the numbers that are less than 3 units away from 0. So if this is 3 here and this is negative 3 here, less than 3 units away from 0 would be all the number between negative 3 and 3. Right, so it would be all the number between negative 3 and 3. But instead of x, we have x plus 1 here. So instead of x, we would say x plus 1 should be between negative 3 and 3. So this is how we translate absolute value in inequality to just the inequality without absolute value. To solve for x, I'm going to subtract 1 from each side of the inequality. I get minus 4. X would be between minus 4, 3 minus 1 would be 2. So all the numbers between minus 4 and 2 would be solution. All the number between minus 4, it's minus 4 and 2. So we can write it as set builder notation like that. You can say x such that all the number, this line means such that all the number between minus 4 and 2, we can write it as an interval notation. Now minus 4 comma 2, we're using parentheses because the endpoints are not included. And we can easily check your answer here. If I pick 0 here as one of the solution, which is within the region we claim is a solution, if I substitute that here, it should make sense. If I substitute 0 here, 0 plus 1 would be absolute value of 1 is 1, 1 plus 2 is 3, 3 is less than 5. Yes, that works. However, if I pick like 3, 3 shouldn't make sense. If you put 3 for x, you don't see that would be less than 5. That confirmed that our solution are correct. All the numbers between negative 4 and 2 would be the solution here. Okay, here we're going to solve the inequality that involves absolute value. The first step is to isolate the absolute value. I'm going to add 3 to both sides of the inequality. So here I would get absolute value of 2 minus x over 4 is greater or equal to 4. Let's see what that means. If I have absolute value of x is greater or equal to 4, that means all the numbers that are larger than 4 units away from 0. So if I look at 4 here and minus 4 here, the number that are larger than 4 units away from 0 would be to the right of 4, like x is greater or equal to 4, or all the number to the left of minus 4 would be larger than 4 units away from 0. So it would be x is less than or equal to minus 4. So similarly, absolute value of 2 minus x over 4 greater than 4 means all the number 2 minus x over 4, instead of x I'm going to put 2 minus x over 4 greater or equal to 4, or I'm going to do the same thing here, 2 minus x over 4, instead of x I'm going to put 2 minus x over 4 and put less than or equal to minus 4. So we need to isolate x here. Now we don't have absolute value in our inequality anymore, we have just the inequality. Right hand side, I can go ahead and subtract 2 from both sides of the inequality. I get minus x over 4 greater or equal to 4 minus 2 would be equal to 2. Now the coefficient of x here is minus 1/4. This is like we have minus 1/4 x greater than or equal to 2. To eliminate that, I need to multiply both sides by minus 4 over 1. When you do that, you want to make sure that you change the direction of inequality to its opposite direction. So it becomes x is less than or equal to, you're multiplying both sides by minus 4. That becomes minus 8. So x is less than or equal to minus 8 is one side. So that would be like this side here that we just found. Similarly, we're going to subtract 2 from both sides of the inequality here. So on the left hand side, we get minus 4 minus 2, that give me minus 6. Greater or equal to, again, minus 1/4 x, or x over 4, or minus x over 4, that's the same as minus 1/4 x. So if I go ahead and multiply both sides again by negative 4, or negative 4 over 1, you notice that the direction of inequality again changes to its opposite direction. So this becomes minus 1/4 times minus 4 over 1 times x. So x would be greater or equal to negative 4 times 6, would be 24. So if you look at your number line, you can locate the numbers now. If this is 0, you're going to locate minus 8, so somewhere around here is minus 8, and 24, let's say it's 24 is here. All the numbers that are less than minus 8 would be to the left of minus 8 would be the solution, including minus 8, and all the numbers to the right of 24, including 24, would be the solution. You can write this as an interval notation. You can say brackets 24 comma infinity, union that with from negative infinity to minus 8. I'm going to use brackets because minus 8 is also included. That would be an interval notation. You can easily check the answer to see if that's correct. If I pick x equal to 0, that shouldn't make sense because 0 is not a solution. So if I substitute for each x 0, I get 2 minus 0 would be 2. Absolute value of 2 is equal to 2. 2 minus 3, I give you minus 2. Minus 2 is not greater than 1. That's good because we're not claiming 0 is a solution. If you pick 25 or negative 9 and substitute that for x, that should make sense. That should be greater than 1. Okay, this is a mixture problem. The solution contains 15% chemicals. How many liters of solution must be mixed with another solution with 10% chemical to make 10 liters of solution contains 12% chemical? For this type of problem, I like to illustrate that by showing these boxes here. And in this case, we're mixing 2 containers to obtain, in this case, 10 liters. So I'm going to write here 10 liters of 12%. This is what we're planning to achieve. We want to have 10 liters of 12%. However, what we have on hand is, I'm going to label this what I have 15% here, and we also have 10% here for the second one. So in this case, I'm going to assume that I'm going to use x leaders from the 15% solution. If I use x leader here, since I cannot exceed 10, the rest should go for the second solution. The rest would be 10 liters minus x. So now I'm ready to write the equation. 15% times x plus 10% times 10 minus x must be equal to 12% times 10. Let's go ahead and write this in terms of its decimal. That would be 0.15. This would be 0.10, and that would be 0.12. Let's divide this by 100. We get those values. So we get 0.15x plus 0.10 times 10 minus x is equal to 0.12 times 10. That's my equation. I can eliminate the decimal by multiplying each term by factor of 10, since I have two digits here, so I'm going to multiply each term by 100 to not have a decimal anymore. So here I would get 15x plus 10 times 10 minus x is equal to 12 times 10. So you get 15x plus, let's distribute that, you get 100 minus 10x is equal to 12 times 10 would be 120. 15x minus 10x, that would add up to 5x. Let's go ahead and subtract 100 from both sides of the equation. I get 5x is equal to 20. Divide both sides by 5. So x would be equal to 20 over 5, which is 4. Don't forget the unit. This is liter. So x was corresponding to 15% solution. So we need to use 4 liters of 15% solution. And the rest would be 10 minus 4. 10 minus 4 is equal to 6 liters of 10% solution we need to use in order to obtain 10 liters of 12%. So here we want to take a look at the graph of y is equal to minus 2 square root of x plus 3 minus 1. Compare that to y is equal to square root of x. If you recall, y is equal to square root of x, the graph would be look like this roughly, and we want to see how does this shift. All right, has shifted up or down. Well, this number here indicate whether you shift up or down. Looks like that. We have the number here minus 1 means that you're shifting 1 units down. 1 units down. So yes, it's shifting 1 unit down because of minus 1 there. We're gonna see if it's shifting to right or left or neither. Yes, we're shifting here. This number here is x minus minus 3. So yes, minus 3 is my shifting. So we're moving 3 units to the left. So from here we shift 3 units to the left. 1, 2, 3. So that would be right here. So this point here would be minus 3 and minus 1 now. And we want to see is stretched, normal, or compressed. Well, looks like that in this case is stretched by factor of 2. Definitely is stretched because this number here is larger than, greater than 1, so this would be stretched by a coefficient of 2, and reflected. Is this reflected? So this would be minus, so the answer would be yes. Is reflecting downward like that. So let's say what else. Find x-intercept. Well, doesn't look like, because if this going down this way, the graph going to be look like this now. It's not going to intercept x-axis, so none. No x-intercept. Y-intercept, yes. For y-intercept, we let x equal to 0 and solve for y. So y is equal to -2 square root of, let x equal to 0 would be a square root of 3 minus 1. So that would be the value of that. You can use your calculator to find that value. -2 times square root of 0 plus 3 would be 3. So let's use our calculator to evaluate that one. Okay, so we can calculate -2 times square root of 3. So that would give me -3.46, and then write -1. So that would be about -4.46. So when x is equal to 0, y would be equal to -4.46, and that would be this value here. That would be where your graph gonna intercept y-axis. So it would be about -4.46 right there. Okay, that the y-intercept would be 0 minus 4.46 then. Is this a function? Well, a function can be obtained by vertical test. If I draw a vertical line through my graph, if I move this vertical line, if it intercepts my graph only at one point and one point only, then considered to be a function. So yes, I use my vertical test to conclude that yes, it is a function. Is it one-to-one function? For one-to-one function, we're going to use a horizontal test. You take a horizontal line and we do the same thing. You take that horizontal line and move it along the graph. If this horizontal line intercepts your graph at one point and one point only at all time, that would be one-to-one function. So the answer to this also would be yes. So the domain would be all the values from -3, I'm going to include -3, and all the way to infinity. And the range would be all the values from all the way from -infinity to this point here, -1. So we can write it as all the numbers from -1 to -infinity. That would be your range. Okay, here we have y is equal to minus absolute value of x plus 1 minus 2. We want to graph this by taking the following step. We're going to take a look at the graph of y is equal to absolute value of x, so we know how that goes. That would be a graph of y is equal to absolute value of x. We're going to shift this down 2 units because of this -2. So we're shifting down 2 units. So we go 2 units down right there. And then we're going to shift 1 unit. Here's x minus -1. So we're shifting 1 unit to the left. From here I'm going to go right there. So this point here would be -1. And here would be -2. And it's open upward or downward because of the minus here. It's going to open downward now. So is this, do we have any stretched, normal, or compressed? Well, there's no factor here, so that would be normal. So we want to find the x-intercept, because this is going to open downward like this. Doesn't look like there is any x-intercept. Your graph is not going to intercept x-axis, so would be no, none, no x-intercept. How about y-intercept? Y-intercept, you let x be equal to 0 and solve for y. Let's do that. If I let x be equal to 0, it would be 0 plus 1 minus 2. That would be just 1. Absolute value is 1. It would be minus 1 minus 2. Looks like we get equal to minus 3. So this point here would be minus 3. Your graph gonna intercept at point 0 and minus 3 on y-axis. Is it a function? We can use a vertical test to see if it's a function or not. If I get a vertical line and take that line through my graph, if this vertical line intercept my graph at one point and one point only, it is a function, so that it is. So the answer is yes. Is this a one-to-one function? We're going to use a horizontal test for that. If I take a horizontal line and run it through my graph, if this horizontal line intercept my graph at one point and one point only, it is a one-to-one function. Oops, it looks like it's not, because this horizontal line would intercept this graph at more than one point, these 2 points, as you can see. So we failed the horizontal test, so it means it's not a one-to-one function. Do we have a vertex? Yeah, the vertex is right here, -1 and -2. That would be my vertex. And the domain would be all the value on x-axis, because it's going to expand both sides. So from -infinity to +infinity, that would be my domain. The range would be from -2 all the way to -infinity. So all the way from -2 to -infinity is my range, and that would be my graph. Okay, here we know if this is function p of x is odd, even, or neither. In order to establish that, if f of minus x turns out to be equal to f of x, then this would be considered to be an even function. If f of minus x turns out to be equal to minus f of x, that would be odd function. So we need to find out what this f of minus x is. So in this case, we really want to find p of minus x, because we have our function named as p. So p of minus x, we're going to substitute for each x minus x. That would become to the power of 4 plus 4 times minus x to the power of 2. Since the exponents are even, you can see that would become like -1 to the power of 4, x to the power of 4, and here would be 4, -1 to the power of 2, and x to the power of 2. Since the exponents are even, so that would be equal to +1, so we get back our same function. This really is p of x. So we concluded that p of minus x is equal to p of x, and that was the rule for the function being even. So this is an even function. Find the cost, revenue, and profit functions for the fixed cost of $300, producing cost of $20 per unit, and selling price of $48. Find the break-even value and graph the cost and revenue function. So in this case, we're going to find C of X would be equal to, it's like mx plus b formula, mx plus b. So C of X would be equal to, it says that each item is $20, so it would be 20x plus, and the fixed number is 300. So this would be equation for C of X. The revenue would be the number of unit, which is 48, so it would be 48 times X. Profit would be the revenue minus cost. So this way would be 48x minus cost is 20x plus 300. So this would be 48x. I'm going to distribute that minus 20x minus 300. So combining like terms, 48x minus 20x, that give me 28x minus 300. And we need to calculate the break-even point. So in this case would be 28x minus 300 is equal to 0. So if I solve for x, get 28x is equal to 300, and if I divide both sides by 28, so x would be equal to 300 divided by 28 is about 10.71. And they're also asking to graph the cost and revenue functions. That's just a graph of straight line, and here would be the graph of cost. As you can see, the y-intercept is 300 and the slope is 20. That's one way you can do that, or you can find 2 points and connect them together. And the other one is for the revenue is 48x, so that just would be the line here to graph. Okay, here we're going to find at which point, what interval this function is increasing, decreasing, or constant. Looks like increasing would be where from -3, increasing would be from -3, I can use brackets, -3 to all the way to -1. This would be where the function is increasing, also increasing from 1 all the way to 3. So I'm going to put union 1 all the way to 3. That would be increasing. Decreasing would be from -1 to 1. So from -1 to 1, this function is decreasing. Also, union that with where else is decreasing. Looks like from 3 to 4 also is decreasing. 3 to 4. This is where your function is decreasing. At any point, it's not constant. find function f and g such that composition of f respect to g or h of x is given to me as 2x minus 3. So it looks like that we have a function that it get cubed. So what we're going to do is we're going to let g of x equal to 2x minus 3, and then f of x, we need to cube that whatever function it is. So we're going to take that function and cube it. So these are the two functions. So let's examine that. F composition of that respect to g is equal to f of g of x. Now we're saying g of x is equal to 2x minus 3. So this is f of 2x minus 3. If I look at my f function and substitute for each x 2x minus 3, so this would be the same as 2x minus 3 cubed, and that's exactly equal to that h of x that was given to us. Given the function f of x is equal to 3x plus 5 and g of x equal to 2x squared minus 5x plus 1, we want to find the first one, f plus g of x. So that means f of x plus g of x. Now f of x is given to me as 3x plus 5. You add that to g of x, which is 2x squared minus 5x plus 1. Just have to combine like terms here. So this would be equal to 2x squared. Here we have 3x minus 5x, that give me minus 2x. We have 5 plus 1, that would be plus 6. So this would be f plus g of x, just simply adding those. For part B, just write it down here, f times g of 2, that means f of 2 times g of 2. Well, to find f of 2, I have to substitute for each x2 in f function, so it would be 3 times 2 plus 5. That would be 6 plus 5. That would give me 11. Then similarly we need to find g of 2. So g of 2, look at the g function, you substitute for each x2. That would be 2 times 2 squared minus 5 times 2 plus 1. Okay. So far we find f of 2 is equal to 3 times 2 plus 5, because f of x was 3x plus 5. So that came out to be 11. So this is 11. G of 2, we said that is equal to substituting each x2 in g function. Okay, so that give you 2 times 4 would be minus 10 plus 1 would be 8 minus 10 plus 1 would be minus 2 plus 1 to go to minus 1. So it looks like we have to multiply 11 by, this would be minus 1. So this would be equal to minus 11. F g of 2 is equal to minus 11. for part C, we want to find composition of f respect to g of x. If you recall, that it's the same as f of g of x. Okay, g of x is given to me as 2x squared minus 5x plus 1. So f of that, I'm going to look at f function and substitute in f function for each x, this right here. So if this is f of x, f of 2x squared minus 5x plus 1, then would be the same as 3 times, instead of x, I'm going to put 2x squared minus 5x plus 1, then plus 5 here. So that would be the same as, I'm going to distribute this 6x squared minus 15x plus 3 plus 5. So that would be 6x squared minus 15x plus 8. This would be composition of f respect to g. So for part D, we want to find g composition of g respect to f of x.
I know
so
you hate matcha, but
okay, for this part here, we want to find the composition of g of f of x. So that is the same as g of f of x. So that is f of x is given to me as 3x plus 5. So to find g of 3x plus 5, I'm going to look into my g function. G of x is equal to 2x squared minus 5x plus 1. So g of 3x plus 5 is substituting for each x, 3x plus 5, and there are 2 places that I have to substitute 3x plus 5 in there, and that would be plus 1. So I need to expand this now. Here I take the first term squared, I get 9x squared. 2ab would be 2 times 3 times 5, that would be 30 plus 30x plus 25, and then I'm going to distribute. This would be minus 15x minus 25 plus 1. Now, that's all I need to do now is to distribute this. It would be 18x squared plus 60x plus 25 times 2, 50, minus 15x minus 25 plus 1. Let's combine like terms. Here I get 18x squared, and here 60x minus 15x, that give me plus 45x. And 50 minus 25 plus 1 is equal to 26. The composition of g respect to f of x would be 18x squared plus 45x plus 26.